Good morning students. In unit 4, next topic we are going to see is electric circuit diagram. For our clarification we need electric circuit diagram. When we are going to draw the diagram, definitely we need some symbols for the electric appliances, is it not? We have so many electric appliances, that is battery, light, etc. etc. To draw those things, we need some symbols, common symbols to use. So you just see these symbols. These are some basic symbols what I have drawn. First, if it is like that, this is nothing but switch. Then this is nothing but symbol for cell. Then battery. It has one long terminal and short. Long terminal, short. This long terminal is plus and this short terminal is negative. Okay. Then this is symbol for DC current, that is direct current. This is symbol for alternating current. This is symbol for bulb. Then this is symbol for potentiometer. Then LDR. This potentiometer, LDR and you will see in higher classes. Okay. Students, this is one basic electric circuit. You just see this. I have connected a switch and a resistor in battery. For this I have to draw a circuit diagram using symbols. So these are the circuit diagram I have drawn using those symbols. This is nothing but we can say cell. This is switch and resistor. Positive end of the cell is connected with this switch through then resistor. Then this resistor, another pin is connected with this negative terminal of the battery. By using these symbols we can draw a circuit diagram like that.
In a circuit. This is a symbol representing a battery which is a 1.5 volt cell. This bigger line represents a positive terminal and the small one represents a negative terminal. This symbol is used for the bulb connected in the circuit. It is just W written upside down in this way and enclosed in a circle. So if we were to draw this simple circuit using the symbols, then how would we do it? Just draw the symbols for the electric cell and the bulb first. Then using straight lines for wires, join them together. This is the circuit diagram representing this circuit. It was simple to draw, wasn't it? You can even show the direction of electric current in the circuit with arrowheads. So the electric current is flowing in this direction from the positive to the negative terminal of the cell. Now we had seen in the past that this is not the only way to light up a bulb in this circuit. For instance, if we interchange the wires connected to the two terminals of the bulb, then the bulb will still glow. This is because the circuit is still complete and all the terminals of the system are occupied. Can you draw the circuit diagram for this circuit? Why don't you give it a try? If you look at this circuit, the positive terminal of the cell, which was initially connected to this terminal of the bulb, is now connected to the other terminal. Similarly, the negative terminal which was initially connected to this terminal is now connected to this one. So how will the circuit diagram of this circuit look like? This is the circuit diagram. Compare it with this one. You see that we've just reversed the direction of the battery. Hence, the electric current in this circuit is flowing in the opposite direction. So the electric current can flow in either direction. As long as the circuit is complete, the electricity will flow and the bulb will glow. Let us look at this circuit now. How many components does this circuit have? Yes, 3. A bulb, cell and a switch. What is the symbol for switch? There are two symbols for a switch. This symbol is used when the switch is on and this symbol is used when the switch is off. If we were to draw a circuit diagram for this circuit, then here is what it will look like. Note that there will be two circuit diagrams for this. This one is when the switch is off and the electric current is not flowing through the circuit. We see that no arrowheads are shown here. This circuit diagram is when the switch is on. Here, the circuit is complete and the current is flowing. The arrowheads are used to show the direction of the electric current, which is always from the positive to the negative terminal of the battery. Now here is a question for you. We know that when the electric current flows between the two ends of the filament heats up. This heating up of the filament results in its glowing, and this is how we receive light from the bulb. But if this filament is broken, then will the bulb glow? No, it won't. This is because if the filament breaks, the circuit will be broken.
Next topic, different electric circuit. We have basically two different electric circuit, that is series circuit and another one is parallel circuit. This is nothing but series circuit. If we connected a bulb, two bulbs in battery in series circuit is looking like that only. If it is series circuit, the bulb is connected one another continuously like that. In a series circuit, the components are connected one after another in a single loop. In a series circuit, there is only one pathway where the electric charges flow. You can see there is only one pathway. When we switch on this battery, the electrons move from negative terminal to positive terminal in a single pathway. So this is nothing but series circuit. Next students, parallel circuit. Already we have seen the series circuit. This is nothing but parallel circuit. In parallel circuit, the components are connected to the EMF source in two or more loops. This is nothing but one first loop and this is nothing but second loop. Okay. Then in a parallel circuit, the sum of the individual current in each of the parallel branches is equal to main current. Just to see the students, in this parallel circuit, it has two pathways. If the battery is switched on like that, current can flow in this first loop as well as this second loop. If the parallel bulbs are connected like this, if one bulb is fused off, the current can flow through another bulb. This is one advantage for parallel circuits. If it is series circuit, if one bulb is fused off, another bulb also will not glow. Next topic students, effects of electric current. This is nothing but where the electrical energy is converted into heat energy. When it will happen? When the current is passed through the resistor, definitely heat is produced because the resistance is opposing the movement of electrons. So the work have to be done to move the electrons in the circuit. That work done is converted into heat energy. By this application, we can convert the electrical energy into heat energy. For example, iron box, water heater, toaster, or some example for effects of electric current.
Students, next topic, chemical effect of current. You just view this diagram. You can see the carbon rod is connected to negative terminal of the battery and the flattened copper wire. Copper wire is made flattened and connected to the positive terminal of the battery, and which is immersed in the solution. You can see that solution into the beaker is nothing but copper sulfate solution. Then by connecting wire, everything is made connected, is it not? So if it is like that you just switch on the battery. After some time you just see some of the copper particles is deposited over the carbon rod. You should note that thing, that is that carbon rod and copper wire should not touch each other while this process. So it is nothing but electroplating of copper over carbon by chemical effect. Next topic, magnetic effect of electricity, that is how the magnetic effect produced by this electricity. You just see this diagram, students. Consider this conducting wire in the first picture. In this, the current is passing through the wire. If the current is passing through the wire, there is a magnetic field produced around the wire. Okay, so this direction of this current is explained by the second diagram. It is direction of current is shown by the right hand thumb. So by the right hand thumb, the right hand thumb is the direction of current, then direction of magnetic field is shown by other fingers of the same hand. This is nothing but right hand thumb rule. This, the direction of current in the conductor, is explained by this right hand thumb rule.
Next topic, students, types of current. We have two main types of current, that is direct current and alternating current. Direct current is also called as DC and otherwise called as unidirectional flow of current. Why it is called as unidirectional flow of current? We know current in electric circuit is due to motion of positive charge from higher potential to lower potential, or electron from lower to higher electric potential. If electron move in one direction, if the charge flow is in only one direction, it will be called as unidirectional flow of current or direct current. Then next, alternating current. If the direction of the current in resistor changes its direction alternately, it is called an alternating current. If the graph is drawn like that movement of charge in the circuit is not in one direction, it will get changed alternatively. If it is like that, the graph is drawn like that. If it is like that, it is called as alternating current or AC current. For electric appliances, we should not use those alternating current directly. We have convert this alternating current into direct current, then only we can use. Students, next topic, advantages of AC over DC. AC means alternating current, DC means direct current. First advantage, voltage of alternating current can be varied easily by transformer. That is, by using this transformer, we can vary the alternating current level. Then next point, AC can be carried over long distance. That is, for long distance we can transmit AC easily. Okay, we cannot transmit DC like that. Then third point, AC lossless. That is, while transmitting, there is a very less, that is negligible loss of AC while transmitting. Then next point, AC into DC, that is conversion of alternating current into direct current is very easy. Then next point, generating AC is easy than DC. Producing alternating current is very easy compared to the production of direct current. Then AC produce electromagnetic induction. That electromagnetic induction you will study it in higher classes, and electromagnetic induction is very base for 12th lesson, 12th 4th lesson. Then what are the advantages of DC? First one, electroplating. What is electroplating? Electroplating is nothing but coating of one metal over another. Then electro-refining. From ore, we can separate the particular metal by using electro-refining. This electro-refining can be done only by direct current. Then electrotyping. Electrotyping is nothing but production of metal parts as it is, that is electrotyping. This electrotyping also done by using the current. Then next topic, dangers of electricity and precaution. You people know the common dangers of electricity and precaution. We can see some of those. First one, damaged insulation. First one, damaged insulation. You know that copper wire is only transmitting the current. It is insulated by some plastic material. If it is damaged, we should not touch that. Then you have to use, if it is like that, you have to use safety gloves for your hands, and while handling with electricity you have to use the rubber slippers. Then next, overload. What is meant by overload? Let's see. Overload of power sockets. That is, you should not, do not connect too many electrical devices. You should not connect so many electrical devices in single sockets. That is, in single switch line. Okay. Then next one, inappropriate use of electrical appliances. That is, use power rating of the devices like AC points. That is, you have to always use the power rating of devices like AC points, TV points, microwave oven points, etc. Definitely the voltage rating must be mentioned while using those electrical appliances. Okay. Next one, environment with moisture and dampness. That means if it is rainy or some other else, if it is very wetness on the electrical appliances, you must be conscious while touching those electrical appliances. Is it not? This is the common instruction what we know. That is, electricity must be kept out of moisture and wetness. If it is the electrical appliances, that must be keep away from the moisture and wetness. Unless otherwise, we will get electric shocks while using those electrical appliances which is in moisture and wetness. This is the common instruction. Is it not, students? We already know this. Then, beyond the reach of children. This is also the common one what we know. That electrical sockets, that electrical switches and other appliances must be keep away from the reach of children, because children doesn't know how to handle the electric appliances. It may be the leakage of current or any other else. So it must be kept away from the reach of children.